NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report. A shuttle to carry men and equipment to orbiting space stations is one of NASA's goals for this decade. When launched into space, the big shuttlecraft could carry 12 passengers and 25,000 pounds of cargo. The Space Shuttle will be unique because it can fly a space mission, return through the searing heat of the Earth's atmosphere, and then land almost anywhere like an airplane. Recently, a 1/10th scale model of the proposed shuttlecraft was prepared for a series of drop tests. The shuttle test vehicle is 13 feet long, has an 8-foot wingspan, and weighs 600 pounds. It is made mostly of fiberglass, including breakaway fiberglass wingtips. These parts can be easily changed to update the model or replaced if any of the parts are damaged. The model was carried to an altitude of nearly 12,000 feet by a heavy-duty helicopter. The drop tests are being made to see how the test shuttlecraft makes transitions from a high-angle re-entry to a level cruise attitude. It will also test the stalling characteristics of the vehicle and give engineers data on the craft's performance while in free flight. There's the drop. On board the test craft are telemetry and command systems, radar, stabilizing and recovery parachutes, and a forward-looking onboard movie camera. All control commands to the model are made from a ground control van near the drop zone. Because it lands nose down, the model uses a crushable nose section to absorb the landing shock. Shuttlecraft drop tests, paving the way for future spaceships that will carry passengers and cargo to orbiting space stations and then return to Earth like an airplane. As jet planes are designed larger and fly faster, an important part of that design will be to assure safe control by their pilots. At NASA's Ames Research Center near San Francisco, engineers test aircraft takeoff, landing, and piloting problems on the ground. The work is done with simulators. One of the largest and most sophisticated is the flight simulator for advanced aircraft.
This simulator is the latest in a long line of developing motion simulators to present the problem to the pilot of controlling a very large vehicle in landing and takeoff phases of flight. The thing that makes it different from any other simulator is the extent of the motion, particularly the lateral travel. It has 100 feet of lateral travel, which the pilots have maintained is necessary in order for them to evaluate certain key problems in handling this class of aircraft. For example, when the pilot wants to experience an engine failure after takeoff, the airplane translates considerably from the center line of the runway in its response to this, and the pilot wants the real motion so that he gets all of his real cues in attempting to cope with the problem.
All the sights and sounds, even the periodic bumps of tar strips on runways, can be duplicated. Flight simulators, on-the-ground aeronautical investigations of future jet transports. This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.